Recording in progress.
Sarah, is it you?
Morning.
Is that you, Sarah?
That was Jan, actually, that said good morning. But good morning.
Well, it's actually afternoon here. What time is it where you are?
Just before 9 in the morning.
Okay. By the way,
Thursday.
as somebody with a PhD in engineering, I agree with every one of your points. It's funny why I ended up leaving engineering, because it's too narrow, too linear. I ended up studying philosophy of science and ethics, the very things that engineers put down. So I agree with what you're saying.
Well, that's a good thing to hear out of the gates, I guess. I can anticipate a sympathetic audience, I guess.
Yeah, I don't know whether everybody will be, but I know there will be members who will be sympathetic, because the focus on technology, I mean, take AI, just the technology alone, and not the ethical and social considerations, is really causing harm. It poses an existential threat, as a lot of people have been claiming. Anyway, I look forward to your presentation.
Thank you.
So hi, Sarah. I'm Peter, and I think we met last time. Rune is currently stuck in traffic, and so he asked me to kick us off. I'm going to wait a little bit longer for others to join, and then I'll do our standard intro, which is everyone giving a little snippet about themselves, and then I'll give a short blurb about CCRM, and then it'll be all up to you.
No worries. Thank you.
Morning, Emery. I think we're just waiting at the moment.
Oh, okay, thank you.
Peter, while we're waiting to get started, can you see my slides? Have I successfully shared those?
Yes, they look good to me.
Thanks.
Hi, Kofi.
Hey, Peter. Sorry, I'm not using Zoom very much, so I'm a little like a fish out of water here. It's nice seeing you.
It's good to see your square anyway.
Let's see if I can get a video going here. Start video. See if that works. I'll do some rebooting.
That's all right. I'll just have to come out and visit.
Yeah, you definitely.
Yeah. So Sarah, we I don't know how it works at Canberra, but but at Berkeley everything is operates on Berkeley time, which is generally 7 minutes. I don't know if we'll wait that long, but we'll give it another minute and then get
It's
going.
fine.
Yeah.
I'm in no rush.
Okay.
I'm good.
Okay, that seems sufficient. So, welcome everyone. My name's Peter. I'm a longtime member of CCRM, former co-director, and stepping in for Rune, who is stuck in California traffic and will join us hopefully soon. So, today we're welcoming Dr. Sarah Maslen, who's an associate professor of sociology at Canberra School of Politics, Economics, and Society. And she will be presenting, you can see the title there, Ways of Knowing, Engineering Practice in the Face of Uncertainty. So as is tradition, let's take a moment to go one by one and introduce ourselves. And I'll just call you out based on the squares on my screen here. So let's start with you, Ian.
Ian Mitrov, member of CCRM. My interests are in crisis management and complex, messy systems.
You, Ian. Paul. Paul, you're on mute.
Sorry about that. Paul Schulman, member of CCRM. In the last 5 or 6 years, I've been particularly interested in the problem of analyzing socio-technical systems when you're either analyzing the social system or the technical system, and we have not achieved much of an integration, much of a cumulative development across the fields. And so I think that's particularly germane to the questions that Sarah, you're raising. And one of the questions is, how do we do that in integrating these variables in these two separate types of learning in a way that allows us to improve technical design? Anyway, that's me.
Thanks, Paul. So Jan was our last speaker, but if you take a moment to introduce yourself again.
Oh, thanks, Peter. My name's Jan Hayes. I'm a professor at RMIT University in Melbourne, Australia. And you're going to hear about my research interests because what Sarah's talking about is work that we've been doing together jointly over more than a decade.
Thank you. Emery.
Yeah, my name's Emery Rowe, and good to have a chance, Sarah, to hear your presentation. And I worked with Paul Schulman for a long time.
Thanks, Emery. Kofi.
Hi, everyone. My name is Kofi Nkabi. I am a member of CCRM, also a principal at Exponent. For the past 10 years, I've been focused on risk assessment and management of energy utilities and infrastructure systems.
Kofi. Mark.
My name is Mark Nichols. I have participated probably for a year or so in these presentations and found them very helpful. I'm a retired safety professional, and my current role is as a member of a freight rail safety advocacy organization based in Minneapolis, St. Paul, dealing primarily with transportation of various hazardous materials via unit trains through populated areas in particular. I also volunteer for American Society of Safety Professionals as a mentor, and I enjoy that role as well, having a chance to apply what I know to diverse situations involving typically safety professionals who may not have had all that much exposure to management systems and how you actually make them work in various types of organizations. Thank you.
Thanks, Mark. Larry. Larry is saying in the chat, I am a retired structural engineer from Denver, Colorado, and spent 30 years of my career working for the National Park Service. Thanks. Sorry about your audio. Okay, Hank.
Hey everyone, sorry, Hank Wilson. I'm driving, fighting DC traffic, so my apologies. This is my first time attending. I am by far the least educated and probably newest member. So I'm a military 20 years, just a fascinated interest in risk management, and read Charles Perrow's book, fell in love, and kind of just do that in my off time. Thanks for having me.
Great, well, welcome. Maureen.
Hello, I'm Maureen Hassel. I'm a professor at the University of Queensland in Australia and the director of UQ's Risk Initiative and the Minerals Industry Health and Safety Centre. So this is my first time attending a CRM session, so I'm looking forward to learning more. We deal predominantly in the high risk or high hazard industries and in the control of hazards, as well as we're moving more into the socio-technical optimization of risk.
Great, welcome. Thanks for joining us. Nick.
Hey, good afternoon, everybody. So Nick Forty, I'm with the U.S. Department of Transportation. I'm a safety engineer. I've attended a number of these in the past, found them very informative and provoking. So I'm hoping this one will be in that similar vein. I've learned quite a bit in terms of doing risk analysis and kind of looking at things through an organizational perspective. So very helpful. Thank you.
Great, well, welcome back. Okay, and as I said, my name's Peter Martelli. I'm an associate professor of healthcare administration at Suffolk University in Boston, and I've been working with CCRM for ages as a student and up till now. So before we begin, let me just give a quick background on our center. The Center for Catastrophic Risk Management was founded in 2005 in the wake of Hurricane Katrina. We're a global group of applied researchers from academia, government, and industry who focus on the messy, complex, multi-jurisdictional problems of the 21st century. So with that out of the way, let me pass it on to Sarah. Thank you.
Thank you, Peter. I've already kind of been introduced. So I'm a professor of sociology at University of Canberra. I've been fortunate enough to be working with Jan Hayes and Andrew Hopkins on a series of projects focusing on engineers working in hazardous industry since 2012. We've had a long-term research connection, mainly with the high-pressure gas pipeline industry in Australia, but also I've done some work with mining and petrochemical companies as well. A major focus of the work that I've been particularly involved with has been around engineering reasoning, by which I mean the methods that engineers adopt to make sense of the problems that they're dealing with, noting that engineers are almost always working in teams. And so this is a collective project. And I should probably also say that I'm a sociologist, and I guess in reinforcing that, what I'm trying to signal is that I'm going to be bringing some sociological theory to bear on these problems, particularly working from phenomenological and interactionist traditions. So you might notice some echoes of this in the work. If there are some terms that you're unfamiliar with and seem pertinent to know, feel free to pull me up. So what I thought I would do today is talk through some of these ideas. The observations that I'm going to be making are building across multiple projects, and much of the work has been published. But that said, today's presentation has a little bit of a character of a work in progress, in the sense that we're in the process of bringing together these collection of projects, this more than a decade worth of work, into a book on engineering practice. And so I'll be looking forward to any thoughts that you may have on connections, framing, significance, anything along those lines. Okay. Before getting too far, I wanted to acknowledge the Ngunnawal people, who are the traditional custodians of the lands on which I live and work. I acknowledge and respect their continuing culture and the contribution that they make to the life of Canberra and the region. And I also wanted to acknowledge the Hutchin people, who are the traditional custodians of the lands on which Berkeley is sited. Okay, so I think most of you probably don't know me especially well, so just a bit of an overview of what we've been doing since 2012 before I get into the specifics. On the screen, there are a list of pieces of work that I've been contributing to over the last decade or so. There are roughly 3 high-level thematics across these projects, and I'm going to be touching on each of these today. The first one relates to learning. So this has been a major concern of the pipeline industry. In fact, that's kind of how I came to this research as postdoc. I'd been doing research about professional knowledge acquisition, and senior members of the industry were really concerned about maintaining expertise, knowing the connection to public safety. So I came in with that as the backdrop. Jan and I have had a long and shared interest in storytelling. We came to stories in the first instance interested in how they're used in informal knowledge sharing. So this is something that I've been investigating myself in the context of mountaineers. And in remarkably similar ways, they're also a way in which engineers and workers in engineering-based industries make sense of failure and their role in disaster prevention. Jan and I have since had a few projects on this practice, including a large current project of case-based learning that's rolling out training packages that adopt different methods focused on stories, and we're evaluating them. And I'll tell you a little bit about that later. Another thematic in the work has been around high consequence engineering decision making. We've been looking at issues like the organisational structures that direct attention in one direction or another, the use and development of industry standards as a way to guide and advocate for certain kinds of decisions. And we've also been interested in matters of liability and their impact on the practices of engineers following a major flood event in Australia in which individual engineers were pursued legally. Some recent topics that have been capturing my attention strongly have been more specifically around engineering reasoning, looking beyond analytic thought to narrative-based reasoning strategies and the embodied aspects of understanding as well. That's what my PhD was on, so it's nice to kind of close the loop on that theoretically. So we've recently also completed a study that is seeking to identify the non-technical capabilities that support engineers to make robust decisions in the interest of public safety, and I'll share those capabilities as well. The last strand of work has been really concerned with engineering ethics. So I know some people in the room are the same as a couple of months ago when Jan spoke. One of the papers we've been working on is looking at lying in the PG&E case, but we've also had some other work on that, including a paper that was looking at how ethical questions are managed by engineers as they're providing advice to senior decision makers. I can't realistically talk about all of this today, but if there's something there on the screen that I don't talk about, feel free to shoot me an email and I can provide your paper or we can talk about it further. So the nature of knowledge and cognition has long dominated the inquiry of a bunch of disciplines: philosophers, neuroscientists, anthropologists, psychologists, sociologists. And as part of these traditions of work, two main ways of knowing are typically recognized, including conceptual and embodied forms. Following Plato, philosophical contributions in particular have privileged conceptual understanding with abstract contemplation at the center of the philosophical project. For Plato, we don't trust what we know via our senses, it's our rational minds that offer a pathway to truth. And a similar line of thought was presented by Descartes, who observed the individual mind as separate from that of the other. So we're talking about a solitary self rather than a collective, and consciousness and reasoning as a matter of pure intellect, once more drawing these sharp lines between mind and body. And so this leads to a view of conceptual knowledge as something that can be formalized and stored in its totality, separate from a person. So knowledge as a formula, as a written idea, in the case of engineering, standards would be a good example of that. So the idea here is that there is knowledge out here and people over here, and there is the possibility of separating them out, and that it won't lose anything in that process of separation. Greek philosophy also recognized embodied know-how or practical intelligence. Phenomenological and practice theories draw these aspects of knowing into focus in particular. And embodied knowledge, which I'm going to talk about more in a moment, has also been lumped in with other forms of tacit knowledge. So these are those aspects of craft or expert understanding that are difficult to articulate or formalized. And we've been pretty quick to recognize that there are tacit aspects of knowledge that underpin professional practice. You might have seen images of icebergs with everything below the surface being the uncodified substrate on which codified knowledge rests. But we've actually been less able to articulate what we actually mean by this. In the more recent history of engineering work, there has been a really dominant view that engineering is more mind than body. So it's dominated by these conceptual, disembodied forms of reasoning. And major reviews of engineering education and the profession in several countries over decades have emphasized this. And their argument has been to say, in focusing on inductive and deductive reasoning, we are not considering most of what the profession is about, which involves what they call the social side of decisions, the more messy negotiations that happen in work groups, how values might guide decisions. In addition to kind of this social, though, there's been a growing literature that suggests that we can't think of technoscientific work as anything other than a craft practice grounded in the body. That is, we need to be pushing beyond acknowledging the social, looking to other ways of knowing that comprise engineering decision-making. And indeed, that there's no separation between mind and body in the practice of knowing, whether we're talking about laboratory work or what happens in a design office. The process of reasoning through problems isn't objective, it's not disconnected from our bodies, and there is this body of work that's wading into this. And I'll just give you a couple of quick touchstones. So shout out to the Californians. Charles Goodwin, a linguist developed a notion of professional vision in a series of papers, one of which was looking at the reasoning of geochemists. Geochemists need to develop both a way of seeing the material that they're working with as well as a feel for it. So they're handling fibre in a reaction tank. And in arriving at a decision over whether the material they're working with has reached jet black, they say what they're looking for is something akin to gorilla fur. And if it looks like orangutan hair, then they're yet to reach the right point. And this reference to gorilla or orangutan fur, this is about encoding colour in the vision of the geochemist, but it's also making reference to fibrous qualities. They're squeezing it, they're manipulating it. We wouldn't call the work of geochemists a trade, disconnected from theory. And so what we need is a way for accounting of these ways of knowledge that are at once conceptual and embodied. Practice can also involve coming together with and seeing technology. And I was interested in what Paul was saying about bringing together the social and the technological, and certainly there's a whole new materialist tradition of research that's looking at that. This coming together with the technology was developed or looked at in Janet Vertase's work on the Mars rover, where engineers and scientists who program the rover do so through embodied simulation, using their own bodies as a ground to see as the rover will. Another thing to note about this is that conceptual and embodied knowledge don't have a universal relation. They vary by epistemic culture. And particularly relevant to the case of engineering, we can observe a spatial dynamic to knowing, which shows up the distinction between the field and the office and the embodied conceptual work that can be involved in managing their separation. Okay, so pointing to these more embodied ways of knowing, when we're talking about professional knowledge, once we get beyond university education, it's experience that is most often given as the foundation for knowledge and expertise. We learn through experience. And this isn't just something that lay people use to account for their understanding. We see this all the time in the literature. Even work that's theoretically wading deeply into how knowledge operates, we get to the punchline of where does this thing come from, and people write, it's experience, right? What's helpful here, though, is looking more closely about what constitutes this experience and the ways of knowing that it's referring to. And I'm going to tell you a little bit about what we've been finding in this respect. Many of the pipeline engineers that we've been talking to describe the virtues of field experience when reflecting on what makes for a robust office-based decision. In their accounts, sensory appreciations of an asset, specific components, and the surrounding environment feature really prominently. And this sensory appreciation is part of what is often more abstract thinking back in the office. Going into the field aids in their visualization of the asset and what it means to work with it. Field experience is important for a very specific reason. It's the ground for an embodied understanding of the physical features of the asset. This issue of visualizing the asset relates to the reasoning that needs to happen as part of the design process. And the significance of it is there when we see where it's missing. So one of the engineers we spoke to confessed spending a year in the design office, never going into the field and seeing what was being designed, the complexity, the scale. And in summary, he'd been designing infrastructure that was borderline impossible to construct. The engineers claimed that this embodied understanding is something that endures once they're back in the office. So they don't need to be taking their computers, laptops into the field and sitting next to a pipeline to build a constructible design or write a work procedure. But they need to be building that embodied understanding for the other ways of knowing to operate spatially separate. Working in the field isn't only about building an embodied understanding of the asset and the geography. It extends to an appreciation of the bodies of workers constructing the pipeline. So this might seem self-evident, but there are not people on technical drawings, and yet they're everywhere once you get into the field. Office-based engineers describe moments of realization that there are workers involved in constructing and operating assets. They begin to imagine an area surrounding this asset as having people with agency, each with their own embodied affects and potentialities, all of which need to be taken into account. An example that came up repeatedly was reasoning over whether it's possible for a construction worker to move to perform a weld as drawn. Field experience gives design engineers a sense of how the bodies will need to move if they draw one line on the page or another. And there's a quote on the screen that captures this scenario. In short, it says the best designers would be the ones that have got the construction experience because they've got the practical experience. You've come up with 3 welds there, but how on earth am I ever going to get in there to do that weld in the middle? It's physically impossible for me to get an electrode in there to weld that up. And that's what we need to overcome. And I want you to note here that in forming this judgment, the engineer shifts position from designer to construction worker. He's saying, how on earth am I ever going to get in there to do that weld? So this is a case of taking the role of the other in the kind of interactionist George Herbert Mead kind of sense, where as a way to kind of assess whether a design is practically buildable. Taking the role of the other is a way of getting a link between my course of action and theirs. These issues of building and working from an embodied sense of the pipeline system were explicitly linked by our engineers to an appreciation of what can go wrong with pipelines and so what they need to attend to so as to prevent failure. Most foundationally, field experience draws into sharp focus the very materiality of the systems that office-based engineers design and their purpose. One person made the comment that they could be pumping Coca-Cola for all the design engineers know, unless they go out there and they see it. Field experience informs the conceptual judgments about the physical state of the system, what can go wrong, and what they need to do to address it. And without that experience, there's the potential for misunderstanding where engineers rely on computer models alone. And I've got a quote there on your screen from our data on this issue. Field experience provides you with a context for understanding what the computer is telling you, but treating the computer as a calculation tool, not as a thinking device. I think that last phase is really critical. And so in this case, there's a sense that the model can actually be more conservative than is needed. In the real world, things don't regularly blow up. And spending time in the field brings a little bit more nuance to that. You know, is this something that we really need to be concerned about or not? Imagining a future self as a test of risk acceptability. So taking the position of an imagined other is also a tactic in risk assessment. Part of making engineering-based risk decisions involves imagining worst-case scenarios, which are almost always about what can happen to somebody else, whether we're talking about construction workers, operational personnel, or the public. And with this in mind, the engineers are not only thinking about the power of an unplanned release of a high-pressure gas pipeline abstracted from the people who would experience it if it came to pass, they're also imagining the physical effects of the disaster on the surrounding people for the purposes of making a decision about whether the risk they're taking is acceptable. The imagined other who is exposed to the risk in question often manifests as a future version of self. So they imagine this future self as physically standing near the facility that they're making a decision about, potentially exposing that self to the physical risk. And there's a quote there on your screen to that effect. Would I put myself in that position? And if you wouldn't do that, then it's not acceptable for anyone else at all. One of the examples that was given in this respect involved hot tapping a pipeline or making a new connection to a live system. In thinking through this, the engineer imagines himself beside the worker who's physically doing the activity. The decision here is about whether it is or it isn't safe, is really challenged for this person by their lack of field experience. In his embodied imagination, it feels scary when he places himself in the seat, but there's a question in his mind as to whether this is about a safety risk to the worker or the lack of understanding on his part around risk management with these kinds of activities. The safety literature would suggest that he's right to feel uneasy there. And so, because there is that real risk involved in this task. And so we would say his embodied imagination is working. So embodied knowledge of the asset, the geography, the people, these are all critical to reasoning processes. And this is what people get from the field. So having talked about the virtues of experience and what we mean by experience, engineering-based work has a bit of a problem when it comes to experience too. And in short, experience can be a really rubbish teacher. If we're talking about preventing rare catastrophic events, experience can be misleading and dangerously inefficient. It's highly unlikely that someone would experience the same precise event twice in their career when we're talking about rare events. And experience can also lead to system defences eroding if barriers are routinely bypassed without consequence. And so for these reasons, studies of design and safe operation of hazardous infrastructure tend to focus on good rules in guiding action and systems of work rather than the know-how of individual workers. But the trouble with this is that it more or less skips over the majority of what is the ground for action, I would say. And so the question then is, particularly when it comes to rare events, are there proxies for experience? Are there ways to kind of gift experience that an engineer would need but can't experience directly, or we don't want them to experience directly? So enter stories at this point. Stories are a key mechanism through which engineers cultivate a safety imagination. They tell stories, they hear stories. Hearing stories is a way to get something of an embodied experience without being there. They're a proxy for experience in that sense. They don't completely cover off what's known through embodied experience, but they're a kind of primer. And if you're talking about an undesirable experience, then I guess you take what you can get. As a learning mechanism, though, stories aren't just a proxy for experience. They do something to experience. They convert it into something memorable and meaningful. They give the experience a meaning structure that draws together the significant implications of individual actions and events. They bring some things into focus. They pull other things out of focus. These stories can be different things. They can be personal in the sense of typically reporting on a small failure or a near miss in which the teller was involved. They can also be about major failures, which for the most part, people aren't directly involved with. Major disasters are memorable because of their tragic consequences and rarity, which is probably pretty self-evident. And the lesson comes from sharing the narrative of the event itself. So the way the disparate details coalesce at a particular time and place with sudden and unexpected force. The literature and storytelling practices tended to focus on the institutional context of storytelling rights, the negotiation of meaning. Organisational life itself has been shown to be an exercise in storytelling, mobilised to limit budget disputes, manage stakeholders, to claim authority. And for this reason, good storytelling is often cited as an essential skill for managers, but workers too use stories to share occupational know-how and responsibilities. While stories are critical, our understanding of their cognitive function and persuasiveness has been only partial in contrast to how we understand other discursive forms. The precise ways of knowing that are drawn on in sense making has been relatively under-examined. And so we designed a piece of research to examine how stories form part of the practice of reasoning through problems. That is, how stories are used in knowing, including in archetypally technical domains like engineering. So with this in mind, we set up some workshops focused around the Überlingen mid-air aircraft collision, a disaster that we anticipated that our engineers, pipeline engineers, would be less familiar with. And we asked them to reason through the disaster, the causation of the disaster. And just quickly, for those not familiar with this case, it's a plane crash. It happened back in 2002 over Germany, killing 71 people. There were many things that contributed to this, but just critical things for the next few slides. There was only one air traffic controller present at the time, and there was project work that took place at the moment as well, taking out a bunch of systems, including their telephone and alarm monitors, which meant that the controller couldn't get help. He didn't know fully that there was a problem, that it hadn't been addressed as he thought it had. And operators at other control towers who could see that there was a problem also couldn't call through to alert the person. And there was also an issue with the digital safety systems that deal with loss of separation. So our use of this case wasn't as directed pedagogically as the case-based learning that I'm going to be talking about a bit later. In short, we showed them a video and then more or less got them to discuss it and figure out why it happened. And the other thing to say about this is that the groups of people that we had in the room were all based around work groups. And so these are people who know each other, they work with each other across the organisational hierarchy. And the data is the conversations themselves that they have after they see the video, looking specifically at how they're using one story as a ground to examine another one. How are they recruiting stories to support their claims? To what degree do they use stories to persuade other people in cases of conflict? One participant said, there's no better way to win an argument than with an actual practical example that you can bring up. So in the discussions, groups were mostly working through the same issues or problems that the case raised for them as practicing engineers, such as the extent to which the procedures were followed, how risk was considered, the function of safety systems, the challenge of speaking up, and the role of expertise. When they raised and worked through these issues, they typically did so using narrative strategies, though they also sometimes referred to abstract principles related to risk management. The first strategy in making sense of the situation was putting self in shoes of a character in the stories. And I've put an example of that strategy on your screen. I'm highlighting the key part there in blue. This person is engaging with the extent to which the air traffic controller involved in Überlingen followed the relevant procedures. And what I'm wanting you to pay attention to is how he is speaking more than what he is saying. And again, there's this shift in subject position. Okay, things are getting hairy. I need to get my mate back. In order to make sense of what's happening, he's retelling the original story, himself acting as the air traffic controller who makes a different set of decisions. And on the back of this, he's exploring why the actor in the original story being narrated didn't do this. If you stick with me for a moment, I'm going to keep following this conversation through. This is the one conversation that happens in one temporal line in the room. So you will have noticed that the workshop participant that I mentioned in the previous slide is more or less saying or blaming the air traffic controller for procedural non-compliance. He didn't get his job and call this other guy back, right? And this is a point of contention in the room. Immediately after this claim, a junior engineer challenges him. So he got himself into that tight situation, or the company got him in by not letting the other guy go and have a sleep. And around this point, we as facilitators drip-fed a few extra facts to advance the discussion. So there was a shortage of air traffic controllers at the time and concerns about fatigue management. And so this practice of one controller sleeping had been introduced and was well known to operations management. Our lead mechanical engineer then went on to reason through his knowledge of previous disaster narratives, and I've put the quote related to this on your screen. Note the analogical reasoning strategy that this engineer is adopting. He's not just saying that they need to formalize deviations from procedures so they can think through the implications and get new procedures in place to call back that second controller. He's jumping to other cases where he can see similar patterns of disaster causation, which both informs his own position and counts as evidence to the claim that he's making. So in this case, the analogous stories that he's referring to are major and well-known disasters. But as this conversation progressed, one of the other group members introduced a story closer to home where a deviation from a procedure was known and tolerated and resulted in a pipeline strike. So these narratives provide even more nuance regarding the management of procedural change, linking the issue both to risk and the propensity to drift into unsafe practices if no formal process is followed for managing changes to procedures. And so through this narrative disagreement, they're resolving ambiguity over whether in this respect, Überlingen was a failure of compliance or a failure of the procedures, and they're settling on the latter. I wanted to note the forms of knowledge that narrative-based reasoning strategies can be applied to. Some previous research has suggested that narrative-based reasoning is best suited to values-based judgments. And what we found differed from this in an important way. So we had cases of the engineers using stories to resolve ambiguity over technical points. And I've got an exchange on the screen along these lines. There was a disagreement between two members of the group over whether a risk assessment at San Bruno would have picked up the risks associated with the failure of the UPS system. One participant, who was a senior process engineer, presented a hypothetical story in which he was undertaking the risk assessment and the engineers should have made in the case of San Bruno. And he reasoned that they wouldn't have identified the risk of the failure because the downstream pressure was still within the allowable operating limits. And an alternative view was then presented and supported with a story by another participant who was a lead mechanical engineer who placed a materials expert in the room who would have asked questions about mechanical properties fatigue. So again, the strategies for reasoning here are based in narrative, and in this case, they're using a hypothetical scenario in which the two of them are kind of stepping into this co-written hypothetical, and they're trying to reason through whether or not they would know there's an issue with maximum allowable operating pressure. If you're wondering why we're now clearly talking about San Bruno here, not Überlingen, it's because the group started to talk more about getting the right outcomes in procedural-based systems through this case as a lens on Überlingen and as a pathway into their own practice. So we've got multiple layers of stories operating one on top of the other to make sense of the problem and what it means for them. I'm going to round out these issues with one last question, and that is the big ticket item in engineering circles. Is the ambiguous nature of stories a problem for engineering knowledge? In a way, stories are the antithesis of visions of objective science. They're open-ended. Each telling brings some things into focus and others out. They're partial, they're ambiguous. And in general, beyond the engineering domain, these traits are seen as a strength. But you wouldn't think of engineering as the natural home of the storyteller for these reasons. In our observations, stories were principally used to explore issues that weren't clear-cut. And in fact, that's why partial and ambiguous stories are seen as a strength, because they open a space for reasoning, focusing on different kinds of lessons. If stories were cut and dried, there would be no need for deep engagement and conversation with peers. However, in the case of engineering, there are at least some answers that are wrong, in the sense that they contribute to disaster. We know they do. And so ambiguity needs some significant resolution. And our analysis showed how audiences and tellers alike actively negotiated this partial and ambiguous character through those analogical reasoning strategies that I've been talking about. So in working through Überlingen, they're selecting and they're testing stories against the details of the new case in order to clarify what this case is a case of. Should we see the actions of the air traffic controller in not stopping project work as a failure to speak up? Or is this a case of an organisational failure to have procedures in place to manage that operations project interface? While both of these are possible realities and have links to participants' own experiences, through analogy, these engineers work to settle on the second interpretation in this case to apply a specific lesson to their own work. Taking the initiative and speaking up for safety matters can be difficult depending on the power relationships, but more fundamentally, they think formal processes for project decision-making should reflect where the needs of the system and where the expertise lies. And the resolution of ambiguity through analogical reasoning is especially important for technical matters where there is a correct course of action in line with natural scientific laws. With all this talk about risk decisions, making risk decisions, the ethical aspects of these decisions begin to loom really large. The ethical aspects of technical work tend to be muted in the sense that engineers are typically working in business contexts where there is an absence of moral content in decision-making scripts. Moral muteness here refers to reluctance for technical professionals and management professionals to describe their decisions in moral terms, even when there are clear moral dimensions. Obviously, we've caught some snippets of this not being the case, talk of blood, potential loss, what this means for making decisions. But it's also the case that we're not part of their organisation. What our interlocutors say to us is outside of their organisational scripts. In fact, there've been one engineer once, he said to me, we were like therapists for them, right? Like it's an opportunity for them to speak what is unspoken otherwise. So this point on moral muteness has been subject to a host of critical work that points out the significance of language, and an example of which is in the Ford Pinto case, where the word problem was forbidden and replaced with the euphemistic label of condition. And this kind of euphemistic language reflects muted or underdeveloped ethical prototypes. In our own empirical work on this, we directly question engineers on whether they recognised an ethical component as part of their professional work. And there was a resounding acknowledgement that this was the case, but it is often implicit. So yes, they recognise that it's fundamentally ethical, but they don't want to talk about it. Most of our interviewees connected engineering ethics to public safety. There were some other definitions around that, but safety was the most dominant. Some expanded on what this commitment to protect public safety might mean in practice. They described potential challenges that they might face with a decision that involves the potential for a pipeline failure in a built-up area. And when making such decisions, they needed to maintain an awareness of the bigger picture. And they did that through various tests, including that test of placing themselves in the shoes of the people who could be affected by the decision. In rare cases, they referred to potentially disastrous consequences of their decisions more graphically, an example of which is on your screen. This engineer is positioning engineering ethics in the context of doing social good through the provision of infrastructure without harm. And he's connecting engineering ethics to the Hippocratic Oath in the medical profession, but noting that unlike the way he imagines it operates in medicine, in engineering, ethics is implicit rather than openly discussed. So it's implicit, what does that mean? What does it look like? So most interviewees addressed ethical matters, particularly those pertaining to public safety, without adopting a language of ethics. That is, without being specific about the ultimate consequence of failures in terms of death and public damage. Using the language of ethics was uncomfortable for some, and I've got a couple of examples of that sentiment on your screen. It's difficult, they confess. It runs counter to who they're supposed to be as engineers, and such discussions are generally absent from their workplaces. So this isn't to say, though, that they don't grapple with issues that have clear ethical implications, or that the uncommon use of ethical language signals widespread unethical practices. That's kind of what we would expect based on the current literature, but we don't believe that that is actually the case. Instead, there's evidence, we think, that engineers address these ethical matters using a technical language. They justified these decisions as in the best interests of getting the required outcome. It directs their attention from values to engineering controls that they have at their disposal to guard against failure. So, and rather than appealing to an ethical compass of senior managers in their organisation, which could be more flaky, they seek to convince through technical facts. Technical analysis and advice offers the most accuracy over the nature of the risk, they think, and renders visible the right course of action. They also see this use of engineering languages or technical language as part of engineering professionalism. An individual may have their own personal sense about what could be an ethical course of action, but their professional judgments need to be communicated in a report form, in a technical form. In focusing on these technical details, they're not only working to make risks visible, they're also deliberately avoiding what they consider to be alarmist terminology. They think that if you focus on consequences, then it's going to be seen as more subjective and more likely to be found wanting with time in a boy who cried wolf type scenario. And what I find interesting about this technical orientation in light of what I've been talking about today with knowledge is that in effect, they're hiding much of their sense-making process about the state of the system and what needs to happen. They know through embodied and narrative forms, just as much as the conceptual, the technical, they make decisions real by putting themselves there. And yet when it comes to the advice that they give, there is a silencing of these ways of knowing. So I said that we've developed a set of non-technical capabilities for practicing engineers. These capabilities are based on interviews with practicing engineers, with our questioning seeking to identify those critical skills that engineers use to form robust decisions in light of public safety. What we came up with is on your screen. I'm going to quickly work through it. We broke our analysis into 6 high-level kind of skills or capabilities. The first is the use of long-term foresighted reasoning, especially in the face of uncertainty, including a focus on the long-term and imagining worst-case scenarios. The second is understanding norms and values that guide action, including the use of technical standards, risk concepts, and working professional ethics. Thinking systematically and understanding interconnectedness. So this one is about understanding the context of decisions and being able to effectively prioritize in complex situations, taking the necessary time to get the right outcome as well. The fourth one there, this number 4, is collaborating with and drawing on the experience of others. This capability acknowledges that engineering work is almost always done in groups and that expertise is the foundation of robust decisions. And so engineers need to be able to build their networks, including sound relationships with colleagues, field personnel, and stakeholders, and know their own limitations too, which means seeking out expertise from others when needed. Number 5, grounding decisions in reality. This one is Jan's favourite, I learned yesterday. It's all too easy for engineers to be based in the office, focused on models and drawings. And in this separation from the field, they can lose their sense of context, the people involved, the geography, all of which I was talking about earlier in relation to embodied knowledge. This capability is about focusing on practical solutions that make sense in context, which again requires imagination, imagining being there. It's also about developing sensitivity to the state of the system and being responsive to small failures. The last one is advocating for action and taking responsibility. This one is about explicit advocacy for public safety and having the required conversations with senior decision makers and clients with that in mind. As we saw in relation to the discussion of ethics, this isn't about telling people that there's a risk of fire and loss of life, so much as holding a technical line of defence. Our purpose in developing these capabilities was to use this as the foundation for some training to try to cultivate the capabilities more or less. And what we've been doing is developing and rolling out case-based training packages with a strong focus on evaluation. That the evaluative aspect is the research component, really. And all of the approaches are focusing around stories. Some are around known disasters, and then also we've been using some fictitious scenarios as well. And I'm going to end today's presentation by telling you a bit about the training that we've been doing. So case-based learning takes many forms, and how you run the case will target different kinds of skills and ways of knowing. The first method that we were looking at were discussion cases, which involve a facilitated discussion following a presentation of case material. Discussion methods are commonly used in business, that is the Harvard method, as well as law and medical contexts. The case material can take different forms, including a verbal presentation. It can be written, it can be in film, and the discussion can have varying levels of intervention on the part of the facilitator, and questions can have different foci. You know, what do you want people to focus on or not as they discuss? The second method that we looked at was role play, in which learners assume roles or characters, as you kind of guess, I guess, and they interact within a given scenario to prepare them for a situation that they may encounter in their future working lives. And the third method has been the development of a serious game. And this involves elements of role play, but it's typically practiced by teams that are tasked with making managerial decisions, such as around the deployment of resources in a given scenario within a round-based or a scene-based kind of framework. And ours is like a digital game. It's a, you know, game. I'm going to talk through each of these in a sec. Oh, now. Okay, so we developed two versions of a discussion case targeting transmission and distribution pipeline engineers. The discussion cases both focused on pipeline failures. We were working with San Bruno and the Merrimack Valley gas explosions. This form of case-based learning is the most self-explanatory, really. So the facilitator works through some high-level details of the case, progressively handing the case over to the participants to talk through and debate the details. And the idea here is that this is about discovery for the participants themselves, that they're finding answers, and also that they're finding connections to their professional practice, rather than this being about a PowerPoint presentation. So we have reflective questions that encourage them to engage with the case, but also to link back to their work environments. The role plays were also based on known disaster cases. The two cases that we were selecting here were the Challenger shuttle loss, which you'll be familiar with, and an accident in an Australian theme park called Dreamworld and their Thunder River Rapids ride. One, you mightn't be as familiar with that one, but basically one of the rafts flipped over, killing 4 people. These role plays were paired with one of the discussion cases. So in the one session, we ran San Bruno and discussion of San Bruno, and then the role play related to Challenger. And then in the other pair of cases, we did the Massachusetts case with Dreamworld. And we were pairing these, keeping in mind those non-technical capabilities, because what happens is capabilities come in and out of focus in different cases, and we were trying to make sure they covered off all 6 in the one day. With the role plays, the facilitators give some high-level information at the outset, then we move into scripted conversations. Participants are assigned a character and a section of the script, and after some time to get familiar with their role, we ask them to, you know, play it out like a desk reading among actors, more or less. And we stop at various points in the conversation with prompt questions that are designed to encourage them to think about what are the kind of key considerations and concerns for their character that they're performing. What are they taking into account? What are they trying to achieve? How are they going about trying to achieve this? So these questions aim to more thoroughly put participants in the shoes of a given actor, noting that engineers need to deal with people who have different positions to their own all the time. And so they need to be able to understand the position of the other in order to relate to it, rather than just thinking that it's clear and it's a technical fact, so here it is. I'm just giving a quick taste of what this looks like. This is an excerpt from one of the scripts for Challenger. And you'll see here that there are different characters, and the text that's indented there, that's the script that the person would read out, and then the italicized script at the end is what the facilitator, in this case me, would read out. We also gave the participants some evidence that the engineers would have had at the time, or they were generating, to support their arguments, so they could assess the situation for themselves and also look critically at whether the evidence they were presenting in this case was adequately persuasive. So I also mentioned this serious game. We teamed up with some RMIT game designers and an industry co-design team to develop hypothetical scenarios that explore chains of events over time, with the aim to encourage a long-term view of decisions, where the effects of decisions can take years to be felt. One of the scenarios that we developed focused on flood risk. I was involved in the writing of this one, so it's just on top of my mind, but here's the story. So, this is made up. So based on some things that have happened in the past that we know from the designers. So in our story, 2 junior design engineers are tasked with conducting a desktop flood study as part of the design process. And so the question is, what do they consider as part of this process? Do they only look within a 2-kilometre radius of the site? Do they look further afield? Do they feel confident in their assessment? Do they recognise that, you know, they're only a couple of years out of uni and maybe they should ask someone else for help? And depending on the outcome of these decisions, they may or may not have recognised that there's a dam 10 kilometres away that, if it overtops, is going to cause major dramas. This leads to a second scene in the scenario where the team are in negotiations with a landholder over a pipeline route and location for a mainline valve. The landholder is wanting the pipeline to run across a lower section of ground with the MLV placed by the creek. So does the design team agree to this location, or are they considering this zone to be at heightened flood risk based on a previous investigation? In the third scene, we ran this for the first time yesterday, by the way, and that's the point in the decision that stuffed everybody up. So that's interesting. In a third scene, we have a safety management study, and you'll see the cumulative kind of effects coming out more strongly here. So there's a discussion about flood risk in the room with operations personnel aware of the potential. And so the question is, did the original design team think that there was a flood risk and commission the flood study? And if so, great. They will have discussed additional protections around depth of cover and the use of concrete weights to protect the pipeline in case of flood. But if not, there's a disagreement. And so the operations person has to advocate for them to go back to the beginning. And of course, there's massive pressure at that point financially and in terms of schedule on that person. And the pressure is leaning towards why we can't go back to the beginning now. So the question is, how do we resolve that disagreement if that comes up? The fourth scene is in construction, and basically the pipeline may or may not be installed to specification. And so do the people on site have a conflict with the construction personnel and check? And if they don't, then what they will find is that it hasn't been installed correctly and the pipeline's going to float, even if they've designed it correctly. And hopefully they do check and it's okay. And the last scene is the flood scenario. What happens is the dam overtops, and depending on the decisions in the game, maybe the pipeline's okay when the waters recede with no damage, but if they've put it down by the creek, the mainline valve will be damaged and there'll be a major operation to move it for the future. They might have also lost the pipeline as it kinked and there'll be a leak. So one of the things that we're well aware of is if you put a group of professionals in a room abstracted from the pressures of their workplace, most of the time they're going to know what the right thing is to do. So the question that I asked everybody yesterday when we got to the game and they all got a generally okay outcome, they just stuffed up the placement of the mainline valve. What I asked them was, are there pressures in your workplace that would mean these decisions wouldn't be straightforward, right? And so we had kind of a conversation about how at each of those decision points, things could have gone differently. If you didn't have enough confidence, if you were trying to do things in a timely fashion, if you didn't want to get into a conflict with the landholder and so on and so forth. Okay, so yeah, we ran it for the first time yesterday, and it was a really interesting thing. I think of all of the story in that case-based techniques, this one was the most compelling to me. You might be wondering about whether these methods for training are effective. I said if the evaluation was important, and certainly this has been our question. So We've been evaluating the work in multiple ways. One of the devices we've been using is written responses to a short scenario at the beginning and the end of the training, and the scenario is on the screen. Before the training, this is basically about pressure to sign off on drawings, the scenario is. And before the training, 3/4 of the participants say that the engineer shouldn't sign off on the drawings. But having said that, about a third, including many of the same people, also try to find a compromise with the project manager. The common compromise was to sign but put a whole cloud on the drawing and extensive notes. Other strategies included doing a risk assessment, comparing risk of signing with the risk imposed with the delay, seeking counsel from someone more experienced, seeking more information, and confirming that the data is really necessary. So this isn't a comprehensive summary of the views, but hopefully gives you a feel for the kinds of bargaining they were trying to do. At the end of the training, when participants revisited the scenario, they were even more convinced that refusing to approve a drawing for construction with important safety data missing was the right thing to do. So, but the focus of the responses had changed in some really interesting ways. They were much more focused on safety consequences of going ahead with the incorrect information. Half of the participants identified it important to consider the worst case scenario, who suffers if it goes wrong. One person even wrote, it brings humanity into it. This shift in thinking reflects the nature of the case studies presented, where the participants were brought up close and personal with potential catastrophic outcomes from a series of small, even banal engineering decisions. The social context of decisions was also front and centre. Participants were recognising that they needed to make the best choice, but also communicate their reasoning to their project manager or the client more effectively than they might otherwise, or the people in the situation had otherwise. They also thought timeliness of communication was more important than they were recognising early on. And this relates to, again, the kinds of things that were coming up in the Massachusetts and Challenger cases in particular. About a third of people were mentioning the need to see the position from the project manager's perspective in order to present data effectively. I was quite pleased to see this learning in particular, this knowledge that you can't just think and persuade in your discipline, but you need to be able to adjust position and know how to communicate with someone else. Again, not comprehensive, but hopefully gives you a sense of the shift in consideration over the 4 hours. And I should say this is just currently based on the discussion cases and role plays because we're only just starting on the serious game. We also conducted short focus groups after the training and then a phone interview 3 to 4 months later. The follow-up interviews were especially interesting to me in terms of whether or not the training had had a lasting impact on practice. Most interviewees had some recollection of the workshop that they'd attended, but the detail was pretty sketchy. Some people couldn't recall anything at all, which meant that in the call I was saying, it's okay that you don't remember. This is not a, it's not a critique of you. So in terms of the overarching message, for some, it was kind of a cautionary tale. That's what they got out of it. We don't want to be like them. The first quote on the screen is about that. Others were volunteering some overarching, pretty high level, typically reflections on what they'd learned, which mapped pretty well to the capabilities that we were targeting. The second quote there on your screen is an example of that. We couldn't get anyone really to name the capabilities. Jan and I, we've actually got some contention in the research team about this. I think some of our colleagues are concerned that they won't name the capabilities. Jan and I aren't concerned because we're more concerned about whether they know what it is rather than they can put a name to it, right? But yeah, that's just something to note. They can't name those capabilities typically. What struck me is that in the interviews, the cases where there was the highest level of recall related to basically where the participant had become a trainer. So there was one engineer who sits in this mine. She had taken the case back to her company, developed her own slides around it, and presented the case herself to her colleagues, and in a way that we would talk about it, meaning connected to capabilities, not wholly technical details. And she more or less gave me the PowerPoint presentation in the interview, so it was a longer call, but she clearly understood the ins and outs of it very closely. This issue of memory is something that I'm still working through at the moment. It's the subject of the next paper that I'll be leading out of the work. Last thing on this, we asked them whether or not they felt it had changed how they understand the relationship between their professional practice and public safety. And most people said no, in the most fundamental sense. They're all professionals working in hazardous industry, and so consideration of public safety is a constant consideration, but it's still important to get reminders, and often, they said. And so that's how it stays in their mind. So it's not an aha moment in the training so much as another brick in their continuous professional development wall, so to speak. Just throw a couple of metaphors in there. It struck me, just to end, that woven throughout each of these things that I've been discussing is the function of imagination. The point on imagination is woven through each of the reasoning challenges and solutions. In telling stories, they're typically crafting something akin to what a Pigeon and O'Leary would call a safety imagination, defined as an ability to link one's action to the potentially disastrous consequences. They support engineers to make the link between small, even banal things and the potentially disastrous cumulative consequences of failed risk controls. Their embodied knowledge comes to act in the form of embodied imagination. They don't need to be physically on site or lifting a component every time they're arriving at a solution. They're in a design office and they're flexing their embodied imaginations, feeding into what is otherwise an analytical form of reasoning. They're transporting themselves, in effect, in their mind into the scene. And they need a moral imagination too. They need to be able to forecast what could happen, the consequences of their technical decisions, even if these are ultimately translated into an explicitly technical practice. And they imagine because the outcomes of their decisions are far from certain. They're imagining different courses of action, including how things might go wrong and the potentially catastrophic consequences for workers and the public if they do. Each of these forms of imagination is more or less hidden in formal systems of work and explicitly articulated artifacts as part of the reasoning process. They don't make links to disasters when they provide advice, except in really exceptional circumstances. They don't say that they're imagining themselves or a loved one there. They don't say that they're adopting the role of an other, thinking about how their body is moving. And yet all of these things are really critical. And so as facilitators, what we're hoping is that working through cases is a way to support these exercises in imagination. Though there's also some additional advocacy that we're need to do around the value of field experience. And more generally to think of engineering practice as beyond tools like standards, you know, to say these things aren't cookbooks, there's stuff that sits underneath them that we really need to respect and support. I'm popping a few references on the screen. As I said earlier, this work relates to a series of publications, and I'm looking forward to any thoughts that you may have. Thank you.
Well, great. Thank you very much, Sarah, for a very interesting presentation. Let me first just check. Rune, are you with us? That's a maybe. Okay. So Rune is still in transit, obviously going through a spot of poor connection, but he should be back on video shortly. In the meantime, I unfortunately have to run to my son's holiday concert. So what I'm going to do is I'm going to just say one thing, which is first of all, I found this fascinating. And if you haven't already looked at the work of Sheila Jasanoff at Harvard about imagination, I think that would be very useful to you. The second thing I'll do is since Ian is on camera, I'll hand him the baton to run the question and answer session, which typically goes as long as people are interested. So Ian can take over, and then when Rune's back, he can take the baton from you, Ian. So thanks very much, and I'll see you next time.
Okay, let me start. I hope everybody can hear me. That I want to say, Sarah, that your talk really fits with experience. I have a PhD in engineering, and all the way along the line, what I heard from engineers, forget about all that stuff, squishy stuff. It doesn't matter. They put it down. All that counts is the objective stuff that we're doing, and we know how to make engineering models and all the rest of that. So the sharp division present from day one when I was an undergraduate to when I got a PhD. which is why I ultimately ended up doing a minor for my PhD in the philosophy of science, because I couldn't put off any longer the kind of issues that you're raising, and I thought they were important. One last thing that I'll stop. My PhD dissertation was a simulation of an engineer, one engineer, of his doing engineering design. And while I didn't include it, I referred to it. He told stories about his different clients. He was designing pressure vessels for physicists to contain a potential explosion. Physicists wanted to shoot beams into a flask of hydrogen. The physicists were old and experienced, let the engineer do the design because they assumed he knew more engineering than they did. Young and experienced physicists came in with a design of their own, and the engineer said, yes, boss, because he knew what it would screw up their experiments. So right away, talk about a moral dilemma, whether the engineer, which I felt he did, should have challenged the designs of his in an appropriate way. So Sarah, I want to say, and let me close, that all along in my education of engineering, I heard time and again, engineers put down the humanities, the social sciences. They were all squishy and soft and didn't matter. Let me stop there. Anybody else wants to make a comment, please raise your hand, so to speak, and please address something to Sarah. Sarah, does what I said make sense?
Yeah, it does. Thank you, Ian. I appreciate it. I'm going to seek out your doctoral thesis.
Okay.
It sounds interesting. Thank
It's
you.
a case of simulation aided engineering design at Berkeley.
Okay. Yep.
Anybody else would like to raise a question?
Ian, can I come in at this point?
Yeah,
Follow
go
up.
ahead.
This was a really great presentation. In fact, so many slides. I'm going to just pick one that I thought was at least provoking from where I'm at and the things that I'm concerned about right now, looking at emergency management issues and and disaster management. And that was the slide where you had the interchange over the German airplane accident. Okay.
Yeah.
And now I'm going to be a little abstract. I want to get to where what the wider point is. No, it's the one where the guy says it was between, did they follow procedures or did they?
Yeah.
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 Further back.
Yeah, that's the second one. So this is the first one.
Yeah. Okay.
Yep.
It struck me, the general point is this, that language where a participant said, well, I would have called, things are getting hairy, I would have called. Another guy comes in and says, well, no, it's actually, how did they get into the situation where this is? It strikes me that the language of that interchange is more of admitting the scenarios are vulnerable to criticism. Okay, that there is a focus in this interchange that you had, not unlike the other ones, and maybe I wasn't listening closely enough, but this interchange focused on dependence and vulnerability. Somebody puts out a scenario in a situation where it actually begs somebody to come in and treat it as vulnerable to other ways of thinking. Now, what does this issue of dependence and vulnerability mean to me? And it's where I'm focused now is, I think this old language in infrastructures are vulnerable, and those vulnerabilities create dependencies, is actually apposite, is actually timely, especially when the counter narrative is now one about interdependence, interconnectivity, and relations, the relational approach. So now let me get specific. What I see here is not only a language of I put out a scenario in a way that makes it vulnerable to being questioned, and the questioner comes in and his or hers is just as vulnerable, okay, mimics the actual vulnerabilities. This is your embodied dimension, mimics and embodies the dimension of infrastructural vulnerabilities, in your case, the airplane accident that happened in air traffic control, okay? They were vulnerabilities. There were dependencies created by those vulnerabilities. How do you answer them? So it's a much more embodied interchange than saying, well, you know, these are interconnected infrastructures and, you know, they have a history and it's a relational. It's much more, in this example, much more transactional than the other examples you gave that seemed to me were more dialogic, more relational. Okay. I'm not sure if that's coherent, but I put that out there. And the reason why I put that out there is not only is it more embodied, this example you have here, the ethics are clear. The ethics are very clear when you talk about dependencies and vulnerabilities. I mean, you may argue about it, but it's very ethical. That language begs an ethics. In a way, interdependence does not.
Yeah.
Okay, so I just leave that to you.
Thank you
Could
for
I
that.
just
That's
make
really
a couple of
interesting.
comments? I really enjoyed your presentation. I found it interesting that while the title was about uncertainty, you didn't actually say specifically about uncertainty. And I want to talk just a little bit about that because I think that's an area that's really important. There's a wonderful saying which shows a kind of an engineering perspective, but by a mathematician and physicist, Wolfgang Pauli, when he was confronted with an argument and he quite derisively said, "It isn't even wrong." The physicist and mathematician in him has an idea of propositions that are indeed falsifiable. And so, to use Ian's term, they're not squishy. They have a term about it. And when my colleagues and I have studied high reliability organization, I found something really interesting in that process. They also had a conception of falsifiability of propositions and what could be wrong. And so I want to say a little, Emery has been working on this too, about the importance of the concept of error.
Mhm.
Error is really important in defining and identifying uncertainty. In these HROs, they were particularly interested in several kinds of errors. Errors of misspecification, errors of misidentification, misestimation, and those would be errors of misunderstanding. And so they had clear ideas of what constituted those kinds of errors and the processes and conditions that could cause those kind of errors. And uncertainty was part of it. Those uncertainties were really critical. And so, for example, when they're thinking about risk, the idea of calculating and discounting a hazard by a probability requires you understand what the hell the hazard is, what the range of it, what the worst case scenario actually could be, as well as the likelihoods of those things. And so, in a sense, for them, it was an error to offer a specific risk number. You need a range of numbers. It's an error not to do that. It represents a misestimation. And so uncertainty can be actually transmuted into something much more comfortable for an engineer, the concept of error. And it seems to me that you have a whole variety of things that could be applied to design in engineering. If an engineer is designing without a concept of the response capacities, if he's designing a technology that requires such precision and speed and control that it exceeds that of human control operators and it exceeds the speed of human organizations, that's an error. And so it seems to me that safety could now be thought of quite differently within the context of error. And you could talk about specific design errors that could be made by engineers that could be recognized by engineers. And I just think that there's a lot of material that we could actually begin to probe that would not only clarify our concepts of understanding, misunderstanding, and uncertainty, but also maybe form the foundation for this integrated approach cumulatively to understanding social technical system that does connect engineers with social science variables. And anyway, that's just a thought.
Well, Paul, have you been publishing on those ideas as of yet?
Could you say that again? My volume wasn't up.
Oh, that's okay. Have you been publishing on those ideas yet? Or I'm wondering if I could have some reading.
Well, I am actually, if Rune would know, I actually gave a presentation. He has an class for engineers, and I finally worked it up into a PowerPoint. And so I've actually been making those arguments there. And I did write an article for Safety Science called Reliability, Uncertainty, and the Management of Error. So that has some of those ideas as well.
Thank you.
Anybody else wants to ask a question or make a comment? It's been a very good presentation. Anybody else?
Sarah, are you, just a quick question. Are you aware of the work of the Warren Centre?
I'm going to say no, but maybe if you say something more specific, I'll go, oh,
okay.
Yeah.
So the Warren Centre has been researching about the profession of engineering practices and ethics for a number of years, and they advise on that in Australia. And they put a report out. I'll just post the information in the chat. They're at the Uni of Sydney. They're just down the road from you, literally. They put a report out on professional performance, innovation and risk in Australian engineering practice. So that report is available on the web if you search the title. It was produced in 2009. So for those, I teach engineers around all this content. So that's one of the seminal reports that we use to help guide teaching, case study reviews, discussion bases on safety and risk.
Thank you.
Anybody else have a question or comment?
We did some research. I'm not sure whether you're interested, Sarah. A PhD called Chris Lilburn did a research on what knowledge do people use when they're managing abnormal situations, and that research was based in a petrochemical refinery, and it really did point to more senior people in the organisation remembering their lived experiences or the stories that they've heard from peers on crews. So this is the frontline personnel responsible, they're engineers as well as operators as well as maintainers. So, you know, the storytelling side I think is really important. There's very little in that research for the management of high hazards. And there's also the cultural element that is of interest too. So in Australia, our Indigenous are very good storytellers. And there's little research on, and their stories are remembered across generations. So there's some potential there. I'd be really interested to know what you do along the lines of how do we make sure our stories are remembered, which you said you were pursuing that memory piece.
Yeah, that's something that that we're really just starting to get into now. I can maybe touch base as that develops, but the problem of memory is currently still a problem.
Yeah, especially when there's high churn in industry as well.
Yeah. And also it's not just churn, it's also as you know, gag orders, effectively silencing of stories, or you know, making it a little bit of a closet practice on some things. So we have events that could be useful stories, and sometimes they're not allowed to be spoken.
Yeah, manslaughter laws will do that to you.
If there are no more questions and comments, I want to thank Sarah for a very interesting and really important presentation. So Sarah, thank you again, and I hope we will have the opportunity to listen to you again. Take care and good evening, and thanks for all the members of CCRM. Take care, and we'll see you at the next presentation. Bye-bye.
Bye. Thank you.